All right, let's talk about 1.3. In 1.3, we actually get to talk about trig functions, right? So we're gonna do a little bit of trigonometry now in our trig class. You've probably seen a lot of this stuff before too, though. A lot of times you're exposed to a little bit of trig in like geometry classes and things like that. And we're really not going to get into too much detail with our trig today, but so let's talk about the trig functions. Now, before we do, I need to give you a couple of facts that you probably know from past experience. But the first of them is called the Pythagorean Theorem, right? Pythagorean Theorem says that if A and B are the legs of a right triangle and C is the hypotenuse of that triangle, then A squared plus B squared equals C squared. So here's a picture, right? You've got the legs of the right triangle. And then the hypotenuse C. So A squared plus B squared equals C squared. So that's something that you probably have memorized from the past. I'm not going to give you any proof of it right now. It's a proof that you may have seen in geometry or something if you took a geometry class. If not, you can look one up online. They're really interesting. There are tons of proofs of this thing. So you could look one up for fun if you're interested. The next fact is that the distance from the origin, 0, 0, to some point xy is the square root of x squared plus y squared, right? R equals the square root of x squared plus y squared. So here's a proof of that fact, actually. Let me do this on a separate page, but here's a proof of the fact that here's a proof of the fact that r equals the square root of x squared plus y squared. So draw yourself a coordinate axis system, and let's say that you have some point, it doesn't matter where you draw it, we'll draw it over here. We'll say this is the point x, y. Now, you want to find r. R is supposed to be the distance from the origin to that point. So this distance here is r. Well, you can make a little right triangle out of this, right? You can drop a little perpendicular line from this point down to the x-axis. And then you've got this right triangle. Now, what are the lengths of this right triangle? Well, obviously this is length x. Since this is the point xy, you have to go over x and then up y, right? So this is length x and this is length y. So you've got this right triangle with legs x and y. Pythagorean theorem tells us that x squared plus y squared equals r squared. And so if you want to solve for r, you would take the square root of both sides. Now you probably know from your college algebra days that when you take the square root of both sides of an equation to solve for some variable, then you have to have a plus or minus sign, right? Like if you had the statement x squared equals 9, you can't just say that x equals 3. X could be negative 3, right? You'd have to take the positive and negative versions are both possibilities, right? So x could be plus or minus 3. And it's the same way here. If we're solving for r, we take the square root of both sides. So r is plus or minus square root of x squared plus y squared. However, r is supposed to be a distance, right? R is the distance from the origin to this point. Distances are always positive, right? Distances are always positive. So we're going to say r equals square root of x squared plus y squared. And that goes for the entirety of this class, okay? A distance, and in particular r, right? We're always going to take it to be the positive square root. That's not always the case of x and y, right? And we'll see some of this later on in the semester. Okay, now with that in mind, we can talk about the trig functions. So this is a definition. Okay, so let's say that xy is a point other than the origin on the terminal side of an angle theta in standard position. So remember, that means that the vertex is at the origin, the initial side is on the positive x-axis. And now xy is a point on the terminal side, all right? The 6 trigonometric functions of theta are sine theta equals y over r, cosine theta equals x over r. Tangent theta equals y over x. Cosecant theta equals r over y. Secant theta equals r over x. And cotangent theta equals x over y. Okay, you'll notice that cosecant, secant, and cotangent are just reciprocals of sine, cosine, and tangent, right? So sine is y over r, cosecant is r over y. Cosine is x over r, secant is r over x. Tangent is y over x, cotangent is x over y. Okay? In each of these cases, r is the square root of x squared plus y squared. Okay? And kind of here's the picture corresponding to that. So let me give you an example of this. So let's say the terminal side of an angle theta in standard position passes through the point -8, 15. Okay, so the terminal side of an angle theta in standard position passes through the point -8, 15. Find the values of the 6 trig functions of theta. Okay, that is our task. Okay, well, first of all, I'm going to draw a picture. You don't necessarily have to draw a picture, but we know that theta is in standard position and -8, 15 is on its terminal side. So -8, 15 might be something like that, right? So this angle looks like that, right? So that's theta. Okay, and we're interested in the 6 trig functions of theta. Maybe I should label this -8, 15. Okay, so that's the point -8, 15. Okay, so the 6 trig functions. Well, sine theta is y over r. So I guess we should figure out what r is before we go any further. I'm going to do some scratch work over here and say, well, I know that r is going to be square root of x squared plus y squared. So that's square root of -8 squared plus 15 squared. So that's 64 plus 225, I think. Yeah. So r is going to be square root of 289. Is that a perfect square? I think so. Yeah, 17. So r equals 17. Look at that. Okay, so r equals 17. So sine theta is y over r. That's going to be 15 over 17, right? 15 over 17. Cosine theta is x over r. So that's going to be -8/17. And tangent theta is y over x. These are just by definition, okay? Tangent theta is y over x. So that's going to be 15 over -8. So -15/8. Okay? And then we can do the same thing for the reciprocals, right? So the reciprocal of sine is cosecant. That's r over y, so that's 17 over 15. Secant is r over x. That would be -17/8. And cotangent is x over y. So that would be negative 8/15. And there you go. Those are the 6 trig function values of theta. Okay. You may wonder, how do we find... So we know how to find the 6 trig function values for an angle theta when we know a point on the terminal side of theta. But what if you don't know a point on the terminal side of theta? What if you're just given an angle? What if you're just given an angle measure, like what is sine of 63 degrees, right? Well, so that's something that we'll talk about a little bit later. The short answer is, you'd use your calculator. The longer answer is, well, you take calculus, and in calculus, you learn how to do a Taylor series for for each of the trig functions, and then you can use that series. And actually, that's exactly what your calculator is going to do for you. However, in this class, what we're going to do is we're just going to memorize certain values. And between that memorization and some identities that we'll develop throughout the course, we'll be able to find the exact values without even having to use a calculator for a lot of these things. So that'll be nice, right? But to sort of wet your whistle a little bit, let's talk about how you would calculate the trig function values for an angle theta if you're not given a point on the terminal side, if you're just told the angle theta has this particular measure. Okay? And before I do that, I need to point the following out, right? We can find the 6 trig functions using any point other than the origin that's on the terminal side, right? So, so in the previous example, we used the point negative 8/15, but there are other points on that ray. Okay, there were other points on this ray that we could have used instead of negative 8/15 if we had known what those points were. Okay, and any of them would have given us the same 6 trig function values. And here's the reason for that, right? So here's kind of a little proof in pictures. Maybe you can't see this very well, so maybe I should draw it again. I think you can kind of see it. So what you've got, so let's say that you have a point xy on the terminal side, right? So then the distance from 0, 0 to xy is r, okay? And we'll call the origin O, we'll call this point P, and we'll call this point Q. So you can make a little right triangle out of that just like we have. This is length x, this is length y, whatever. And then let's say that you have a different point on the same ray. We'll call that x prime, y prime. And so we'll call this point P prime and Q prime. And we'll call the distance from here to here r prime. Well, so what you have is 2 similar triangles, right? You've got this triangle right here, and then you've got the bigger triangle here. They're overlapping each other, but they're obviously similar triangles, right? Because this angle is the same for both triangles. These angles are both 90 degrees, and these angles are obviously the same because if you think about it, this is a transversal, and these are parallel lines. And so these are, what did we call these? Corresponding angles, and so they're the same, right? So OPQ and OP prime Q prime are similar triangles. And so what that means is that the ratio of their corresponding sides are the same, right? So like y over r would be the same thing as y prime over r prime. X over r would be the same thing as x prime over y prime. Or, sorry, x prime over r prime. Y over x would be the same thing as y prime over x prime, and so forth, because these 2 triangles are similar. So it doesn't matter what point you use on the terminal side. What really matters is the angle theta, right? And that's why the 6 trig functions are functions of theta and not functions of points x and y. All right? So with that in mind, let's find the 6 trig function values for a 45-degree angle. So find the 6 trig function values, trigonometric function values. So I'll abbreviate those words often. But find the 6 trig function values for a 45-degree angle. All right. So in order to do that, the first thing we need to do is figure out a point on the terminal side of 45 degrees. And it doesn't matter which point we use, it just has to be a point on the terminal side other than 0, 0. Okay? So how are we going to do that? Now let's draw a picture. So 90 degrees is this, 45 is half of 90, so it should kind of bisect that, I suppose. So this is going to be a 45-degree angle. If I take some random point like that and then drop a perpendicular, notice that this would also have to be a 45-degree angle, right? Because 45 plus 90 is 180. That means that this triangle is isosceles, which means that this side and this side are the same measure. So that means that in order to be on the terminal side of this angle, you have to go over and up the same amount. So maybe you go over 1 and up 1, or maybe you go over 5 and up 5, or maybe you go over 1732 and up 1732, right? So this point could literally be whatever you want, right? I'm just going to call it 1, 1. So I know that the point 1, 1 has to be on the terminal side of 45 degrees. And so does 2, 2, and so does 3, 3, and so does 1.74 and 1.74, right? All of those points are on the same, are on the terminal side. But I'm going to use 1, 1 because I think it'll be easier in our calculations. So now what's r? Don't make the mistake of calling r 1. It's not 1. We're saying this is 1 and this is 1. So r would have to be square root of 1 squared plus 1 squared. R is going to be the square root of 2, right? So r is the square root of 2 over here. But now we can find the 6 trig function values for our 45-degree angle pretty easily, right? We can say, well, sine theta is going to be y over r. Now, most of the time, your book will rationalize these. I don't really care if you rationalize it or leave it unrationalized. It's all the same to me. But your book will rationalize it, which means you can't have a radical in the denominator. So it'll multiply by root 2 over 2. And so it'll give the final answer as, well, 1 times root 2 is root 2. And root 2 times root 2 is just, root 4, which is 2. So the book will give the final answer as root 2 over 2. Okay, but there's sine theta. Cosine theta is x over r. So it's the same thing as sine theta, root 2 over 2. Tangent theta is y over x. Well, that's just 1. Okay, cosecant theta is r over y, so that's just root 2. Secant theta is r over x, so again that's just root 2. And then cotangent theta is x over y, 1 over 1, which is 1. Okay, so those are the 6 trig function values that correspond to a 45-degree angle. But just to convince you that, you could use any point on this line. So as long as you're going over and up the same amount, it'll work. So, for example, I'm going to extend this out a little further. And we could use, like, instead of 1, 1, we could use 1.5, 1.5. It might be a little ugly with r, but let's see what r is for that. R would be square root of 1.5 squared plus 1.5 squared. So that would be the square root of 4.5. I wonder, square root of 4.5, what is this? Oh, that's nasty. No, I'm just going to leave it. Square root of 4.5. Okay, so what would sine be? Well, sine theta would be y over r. And you're thinking, that doesn't look very much like root 2 over 2 to me, but I bet once we rationalize this, we can get it to be root 2 over 2. If I multiply by root 4.5 over root 4.5, this is going to be, well, 1.5 times root 4.5, whatever that is, all over 4.5. I wonder, 1.5 over 4.5. is 1/3. That's interesting. So this is root 4.5 over 3. We'd have to do some kind of messy algebra to get this to be 2, I think. How could we force it to be 2? How can we force this to be 2? 4.5. So, ooh, this is tricky. So 4.5 is so 4.5, so that's 9 halves. Okay, there we go. So I can, okay, so if we just rewrite it as a fraction, I think this will work. So this is the square root of 9 halves over 3. Square root of 9 halves. So this is root 3 over root 2 over, root 9 over root 2 over 3. Root 9 is just 3, right? So this is 3 over root 2 over 3. Or in other words, 3 over root 2 divided by 3, which is the same thing as multiplying by 1/3. 3's cancel. There you go. You get 1 over root 2. 1 over root 2, just like we had up here. Anyway, I'm kind of going off onto a little tangent there, but the point is, yeah, you could use any point on this line, and you should still get the same value for your 6 trig functions. Okay, for angles other than 45-degree angles, that whole process is a little trickier. So we're gonna not really worry about it for now. We'll come back to it a little bit later on. Okay, but there are certain values that we could figure out pretty easily. So let me just give you one last example for this section. So let's find the trig function values. I should just abbreviate it TFV, trig function values. TFV for 270 degrees and an angle theta in standard position that goes through the point 3, 0. Okay, so find the trig function values for 270 degrees and for an angle theta in standard position through 3, 0. Go ahead and give the video a pause and see if you can work those out. Okay, so here's my solution. 270 degrees is this angle. To find the trig function values of that, I just need to choose a point on the terminal side. So the terminal side happens to be on the negative y-axis here. So any point along the negative y-axis will do. I'm going to choose the point 0, -1. Right? That's on the negative y-axis. So I can use that point to find the trig function values. All right. By the way, I should point out that r, remember r is the distance from the origin to this point. Well, obviously, if this is the point 0, -1, then r equals +1, right? So sine theta would be y over r. That's just -1. Cosine theta would be x over r. So that's just 0. Tangent theta would be y over x. Ooh, problem, right? -1 over 0 is undefined. So tangent of 270 degrees is not defined. You can verify that on your calculator if you want. But anyway, cosecant 270 degrees. That's going to be r over y, which is again -1. Secant 270 degrees is going to be r over x, ooh, undefined. And then cotangent 270 degrees is going to be x over y. Well, that's just 0, okay? So there you go. Those are the 6 trig function values for an angle of 270 degrees. Now for part B, we want an angle theta in standard position that goes through the point 30. So for part B, I know that it goes through the point, I know that the angle I'm looking for goes through the point 30. So there's a point on its term. So the initial and terminal side are the same side in this case. So whether that's 0 degrees or 360 degrees or whatever you like, 720 degrees, whatever, -360 degrees. But that's that angle right there, right? That's what that angle would look like. So it goes through. It says it goes through the point 30. So let's. Oh, and by the way, r again would be 3 in this case. It's just the distance from the origin to that point, which is obviously 3 units. So sine theta is going to be y over r. Cosine theta is x over r. Tangent theta is y over x. Cosecant theta is r over y. Secant theta is r over x. And cotangent theta is x over y. Okay, and that's that one for part B. And that'll do it for this section. Okay, we'll talk about this some more in the next one.